Some announcements. Triad ends in 2 weeks, actually 2 weeks and a day, which is the 29th of October. This is a reminder that all missing assignments will turn to a 0. You cannot fix it after the triad. Oh, you should email me because comments don't come to my email. But email me and then I'll fix it. So you have 2 weeks to fix any missing assignments. Also, remember that all retakes have to be completed by then. So if you're planning on retaking Unit 4 test or Unit 5 test, or even Unit 6 test, that will all be in Triad 2. Okay, so make sure you're planning for that. I know some people are still missing notes, some people are still missing achieves, so you really need to get all that done in the 2 weeks. Okay. 6A syllabus statements. I went through yesterday and I graded 4, 5, and 6A, except I chose not to put 6A in because it's not great. 4 and 5 were pretty good. Okay, you guys got, I can't remember the score, but it's in Aries. 13 and 11. Okay, so 13, probably good, not hurting you too bad. 11, maybe we can fix that. Syllabus statement 6A, I decided to not put in because it's not good. So I want to go over that really quick. I need this, I'm going to say Monday because your test is Monday. Actually, I'm going to say Saturday because it should be fixed before your test. Okay, so you have a couple days to fix. Let's look at that real quick. Okay, so this slide looked good. This slide looked good. This slide was good. This slide has a comment. 2 images missing. 2 images on every single slide. This one, there is a section where it is incorrect, where it says for processes which involve mitosis, we were looking for the wound healing, okay, or the growth, okay. Next slide looks good. This one, we had a problem with metaphase. Metaphase was described wrong and it was not, you just have to fix metaphase. Go back and fix that. This one was fine. This one never got done. This one also is missing 2 images. Also, this second bullet point was not answered. And so for the second bullet point, I did put a helpful comment on what I would like to see for that second bullet point. Okay. Next slide. Way too much on one slide, also missing images. So I would split that into 2 slides and put images on each slide. Also needs images. I don't know what happened this unit, but your other units were way better than this one. In terms of vocab, remember, if you got to your slide and you haven't done anything, go to vocab. There were quite a few people who wouldn't even get the 7 points because they didn't contribute at all. So you have till Saturday to fix your syllabus statements and make them look better. And I see that some of you are on it right now. I would rather you not do it right now, please. We have notes to do, so you have to do this in your own time. So I am going to say, please close those Chromebooks. I don't want you working on homework or notes or anything, except for what we're about to do together. Okie dokie. So unit 6B, remember you need to do this part for homework. All right, so you guys went over Monday, right? Monday, you guys did oncogenes and tumor suppressor genes. You looked at the analogy of brake pedal on and off, okay? So I want us to now, we're gonna annotate an image that is like an example of that. So remember, our Chromebooks should be closed now. Alan, are you still moving out of this class? Okay, because then I understand if you're on your Chromebook, if you're not doing it. But everyone else, we're doing notes together. So remember, we have this process of going from DNA to RNA to protein. Okay? DNA gets transcribed into RNA, which gets translated into a protein. So we want to remember that process in understanding this next picture. All right, so you have this in your notes. This is the top picture. You have two pictures we're annotating. So the top picture, you want to put normal P53 in that box. Okay, so remember we had the cyclins and the CDKs, and that's your checkpoint, right? Our cell cycle is controlled by a series of checkpoints. So the cyclin and the CDK coming together will cause movement to the next stage. This is a normal tumor suppressor function. So suppressor, right? Stopping, suppressing something. So normal situation, you have what's called a CDK inhibitor. Okay, so the CDK inhibitor is stopping the cyclin D and the CDK from doing what it normally does. So it's stopping cell cycle progression. That's why we have an X on this arrow here, stopping cell cycle progression. So in this case, this is one of the stages in where your cell will be able to respond to damage. So it says if there is DNA damage and therefore should not continue to divide, right? We don't want to divide bad cells. The P53 protein causes DNA to make a CDK inhibitor. Okay, so we notice the cell is bad. We want to stop it from dividing. So you have this protein causing DNA to make this inhibitor. The inhibitor binds to the complex, preventing the phosphorylation, which prevents movement to S phase. This is a good thing. We want to stop this, right? We don't want these tumors, so we want to suppress these tumors. So what happens? We have this P53 protein, and it causes this event to happen, which is the halting at G1. So it doesn't necessarily kill that cell. That cell can still live in your body, but at least it won't divide uncontrollably. Also, it can start DNA repair if that is a possible option. Or apoptosis can happen. If you did your reading, you should know what apoptosis is. Apoptosis is basically controlled cell death. Yes. And because of those options, we don't pass on our damaged DNA, which is good. We don't want to pass on damage. What I always find very interesting is, how does our cell even know? Like what? How does it know that it's damaged? How does it recognize that? And how does it know for this P53 protein to have all this other stuff happen? The short answer is biochemistry. It's all chemistry driven, but it still just kind of blows my mind thinking about how our body at a microscopic level can seem to know these things and respond to them. Sometimes, right? Sometimes this process fails and we do get tumors. But in the best situation, this is what happens in most cases. All right, are we all annotated? Okay. So remember, this is the normal situation. What can happen is you can have a non-functional P53. So if you have a mutation somewhere in your DNA, it can actually mutate your DNA such that your P53 protein does not work. So P53 is mutated, so it doesn't do its job. Basically, everything that we saw happen in the last picture doesn't happen. So our DNA gets damaged, our P53 doesn't work, so our cyclin CDK complex functions correctly and the cell moves to the next stage, which is not good. Now we're dividing bad cells and they can build up to become a tumor. So thinking back to our car analogy, in the normal situation, what is that like in terms of a pedal? In the normal situation, that's like us having our foot what?
Yes. Yes. Yes.
On the normal P53, are we letting the cell move on? No. So on the brake. So the normal P53 would be like when we have our foot on the brake, when we need it on the brake. You're stopping at the stoplight because you see a stoplight and you stop. In our non-functional P53, what is that like? Our foot is either not on the brake or on the gas. You could probably go either way with that one. So we see a red light, but we don't stop. And now we go through the intersection and crash happens and bad things, right? This is us not putting our foot on the brake. We're not stopping the process when we should stop the process. Okay, notice the little angry face. All right. I would say at this point, we've kind of hit the difficult part of the unit. The hardest part of this unit is understanding how the checkpoints work. The cyclin CDK, progressing to the next section, and knowing that mutations, not controlling that will lead to cancer. Okay. So I think the difficult part of this unit has been covered. But now we're going to get into cancer progression. So when our checkpoints fail, this is what happens. We do need colors for this one. I should have had you get a color box. Send one person to get a color box for your group. Your set is on here. Sometimes we have time to build a review. That's always my goal. But just so you guys, if not, anything else is your. All right, see, we need orange, then blue, orange, blue, pink, green. I don't know. It doesn't actually matter what colors you use because the point of the colors is just to separate the different processes that we're seeing. So if you don't have a color, just swap it for another color. I would not choose yellow because you're writing in that color. Your other option is you could write in black and highlight, but I don't know if you have that many highlighters. So. Okay. So basically, this is the flow, the process of cancer progression. I believe on a test, this might look like, what is the correct order of the steps? What comes first? What comes next? What comes next? So the first thing that happens is there is an exposure to a carcinogen. So color that box or box it. I don't know why that one's colored, the other ones aren't. It doesn't. You can color it in or not. So a carcinogen, we need to know what a carcinogen is. A carcinogen is just a substance that can cause cancer. You have some examples over here. You want to make sure you know that there are different kinds of carcinogens. We have chemical carcinogens. Radiation is a carcinogen. Also viruses. Yeah, that would be, asbestos was really, really common. but it's a little less common now. But we still work with asbestos. If you know someone in construction, they might. And you really want to make sure you wear a good mask for that.
You still get cancer from standing in front of the microwave for too long.
I don't know. I know they said it's like when it's done, you don't want to open the door and stand right in front of it. I don't have a microwave, so I don't really look into it.
You don't have a microwave?
That's what everyone says. You don't have a microwave? I don't have a microwave. It's unnecessary in my household. We don't eat hot pockets. You make dinner? Right now, Mr. Lazier makes dinner. I haven't made dinner in months. I am too tired when I get home. He's good enough that it's no, he really is. He's a good cook. The only complaint I have is sometimes it's more healthy than I would like, but it's better that way. It always has lots of veggies and like all the good stuff. So he is a very good cook. Just sometimes I want like fried chicken and mashed potatoes. That's not always what we get. Last night he made bean, cheese, and rice burritos. And then I felt bad he burnt his and mine was perfect. Okay, so first thing that happens, carcinogen exposure. You are exposed to a carcinogen. Okay, second thing, we have initiation. One cell has its proto-oncogenes and or tumor suppressor genes mutated. So a cell has a mutation in one or the other of those types of genes. So we call that initiation. So sometimes you can be exposed to a carcinogen and you get lucky. There's a lot of cleaning products that sometimes we use and it doesn't immediately cause cancer. Kind of depends sometimes on the length of exposure and how often you are exposed. If you breathe asbestos for 1 second of your whole life, probably not going to get cancer. But if you work in a field where you're constantly being exposed, more likely to get cancer, right? So down here, don't forget this part down here, carcinogens will trigger mutations. So that actually kind of leads us up to our initiation. If the carcinogen that you are exposed to causes a mutation, then we call that initiation. Like we have a mutation in the tumor suppressor or the proto-oncogene. So now our pedal is not functioning as it should. We're either on the gas or off the gas when we should be on the opposite. So this picture here is just an initiated cell. It's initiated because it has mutations. So you want to relate the word initiation with actually having a mutation. Okay. All right. Next color is real short, promotion. You guys know like 8th grade promotion, right? So you know what that word means. That means that the mutations have been accumulated. When you think about a promotion, you've accumulated enough knowledge to move on, right? In this case, you're accumulating enough mutations that it's actually affecting you. Sometimes you get lucky. You can get one mutation and your body would be no different. But when you get an accumulation of these, probably because you have multiple exposures, then we call that promotion. Okay. So back to the beginning review. We have exposure. Exposure causes a mutation, which we would then call initiation stage. Then initiation accumulates, those mutations from the initiation accumulate to cause promotion. Moving on to the next. All right, now we have conversion. Notice that in this next color, which is green for me, you are boxing malignant tumor. Sorry. Malignant, is that the good kind or the bad kind? Bad kind. You have a tumor, the doctor says you have a tumor. Next thing you ask is which kind. You hope they say benign. That means it's not spreading. A lot of times they can take it out, depending on where it is, and you'll be all right. If it's malignant, that means it is spreadable. Okay, so we don't want malignant. So conversion stage is uncontrolled cell division. Why is the cell division uncontrolled? Because our genes have been mutated. Our control genes have been mutated. We have our foot on the gas, but we should not have our foot on the gas. That's going to lead to a tumor. Okay, so your malignant tumor there. So this was showing you a lung tumor, but it could be many different places in the body. All right, moving on to our last stage, progression. This is when you would hear about cancer spreading, okay? If you catch cancer early, usually it's confined to one area. If you didn't catch it early, oftentimes the doctors will say you have cancer and it is already spread to these different parts of the body. So that's what progression is talking about. We have tumor becomes malignant and can spread to other tissues. So as you can see in our drawing here, our lung cancer has now spread to the brain and to the liver. Is that the liver or the stomach? I think that's the liver. There's no stomach in that. It's a stomachless person. So this is what can happen. This is what happened. My aunt, she currently is the only person in my family that I know had cancer. She got breast cancer. She got it treated. It went into remission, came back and spread. Mostly what killed her was that it got into her bones and her bone marrow. And then that just was kind of the end. Also, she was very old, so it was more difficult for her to fight the cancer. Go ahead. And I guess we do have another extra color down here. I didn't notice this red. Metastasis, you should know that term. That means that's the term for the spreading of the cancer. I mean, as long as you know that this isn't exposure, it's separate. And that goes with the color of these arrows. Arrow from lung to liver and lung to brain. All right, I'm gonna make sure we're all. All right, in a moment, I'm gonna have you cover your paper and ask you some questions. Take a gander. It's stored in your brain. Good, answer you. How do you do that? Thank you. Also, this is unfinished. Oh. All right, you have 10 more seconds to gander. Store to your brain. And I'm going to ask you to flip it over. All right, flip those notes over. No cheating. I'm not going to call on cards today. They're way over there. Unless someone wants to bring them to me. That's okay. All right, in order, please tell your table. Oh, it's flipped over, flipped over. What is the order? You have 5 stages of cancer. Tell them in order. Ready, go. All right, take a pause. I'm going to give you the letters. I'm going to give you the letters. CIPCP. C I P C again. Or no, the only C, sorry. And then P. So what's the first one? Carcinogen exposure. 2, initiation. 3, promotion. Or C, when it goes from the mutations are actually having an effect on your body. Conversion. And the last one, progression. Very good. Okay. In which of these stages is it the accumulation of mutations? Promotion. Very good. Which one is it when the tumor becomes malignant and spreads to others? Progression. Very good. In initiation stage, what are the 2 types of genes that might be one or the other is mutated? Proto-oncogenes and tumor suppressor. One of those 2 got mutated. All right, very good. Okay, the next thing we're talking about is cancer and age. Can cancer happen at any age? Yes, but we see a trend that it is more likely as you age. Okay, so cancer correlates with age. You have a bubble. In that bubble, I want you to write the bold. Age is the biggest risk factor. When you think about the progression, right, it goes based on being exposed a lot. So when you are young, you haven't had much time to be exposed as much as you age, your exposure becomes increased. Also, other things like your body is just not as strong as it was before. It doesn't have necessarily the ability to take care of things. Like we just talked about how sometimes your cell can notice that you have damaged DNA and it can do something about it, right? As you age, all of those processes kind of slow down a bit. So there's multiple reasons why age, but age is the biggest risk factor. And as you can see here with this graph, the age at diagnosis, we have males in blue, females in pink. Interesting that males are much higher as they age, but then at a certain point in the 85s and 90s, females then are the top in cases. All right. Good question. I don't have the source on it. Well, for example, don't smoke or vape. That's a good way to get cancer. Well, smoking or vaping. Drinking is a good way to get cancer. Lead a healthy lifestyle. I've read bananas. Bananas are very good, healthy fruit, right? I have read that the more brown and spotted they are, the more cancer fighting they are. I haven't obviously tested that in my own experiment, but that's what I hear. I've heard it many different times, which I was like, yay, I like the brown spotted ones. I know some of you guys like them like my mom likes them like green, like very early. Yeah. Oh yeah, if like a water bottle in your car, because the toxins from the plastic can leak into the water. So you never want to leave water bottles in your car. If it's like a thermos, I'm looking for the word. Hydro flask, thank you. If it's a hydro flask, I think you're fine. Maybe not a cheap one though. You want to check your hydro flask. The actual hydro flask brand is good. But yeah, you don't want to drink out of melted water bottles. Yeah, and just be careful around like cleaning products. And like I remember one time I was cleaning my bathroom really good and I literally started getting like dizzy and lightheaded, which was probably bad. So you just want to be careful with what you expose yourself to. Also skin cancer, right? We'll talk about that. So just try to lead the healthiest life possible. But cancer really can happen to anyone. There are people who have smoked 0 cigarettes in their life and they still get lung cancer, because we can also get it from pollution in the air and other things as well.
Okay. Multiple hit hypothesis. Is this something we're writing down? Oh, why? You have underneath your graph, go back to your graph. Underneath your graph, it says why, and there's a link. Yeah, I think just right underneath the link. Multiple hit hypothesis. See, it says in red. This is the answer to why. So put multiple hit hypothesis equals cancer is the result of the accumulation of multiple mutations. So as you get older, you have more time for these mutations to accumulate.
You might have mutations in your body right now that could lead to cancer later on in your life, but they're not going to affect you until they accumulate. Never know. One of the things I watch every morning, the news. This is how I know I'm getting older. I actually watch the news every morning. It is. No, it's good. I used to watch it because my mom watched it, but I didn't really pay attention. At some point in my life, I woke up and I'm like, I have to have the news in the morning. If I don't watch the news, I just feel like my whole day is messed up. But I always like to watch the weather. That's important. And part of the weather, they'll tell you the air quality, right? So today's air quality is actually not great because there's fires up in Santa Barbara and all that smoke is coming to us. So on days where maybe I would have the windows down in the car, today would probably not be one of those days. I don't want to get lung cancer from smoke, from fires.
Did you see there was so windy a tree had fallen over and it like landed on 3 or 4 cars?
No, I did not see that part. I actually woke up late today, so I barely made it in time for the weather. I was like, hurry, turn it on before the weather's over. Yeah, it was super windy. That's the other thing it's saying is that today and tomorrow are high fire risk because of that. Trees can hit power lines and things like that. And also if a fire starts and it's windy, that's bad. We don't want windy fire days. Yes. Yes, smoke inhalation is really bad. You also see like in firefighters, a lot of them have to quit because they get lung disease leading to cancer. Yeah, it's an issue. And they do the best they can with the masks and everything, but it's hard to stop it completely. Okay, so this is why. Cancer develops in older people simply because of their prolonged exposure to carcinogens such as sunlight, radiation, environmental chemicals. Also, the environmental chemicals used to be a lot worse. We're getting smarter as humans and we're like, oh, that caused cancer. Let's stop doing that. Substances in the food we eat. Did you guys hear the FDA is passing a law where they're decreasing the salt? So over the next 2.5 years, processed foods have to cut their salt by like 12%, which doesn't seem like a lot, but it's a good start. Yeah. I can always put extra salt on it, I know, but mutations also occur as a result of random errors. Also, that's going to just be more likely to happen as we age. Okay. Something about elephants. They have a zombie gene. We don't really have time to go into this because I know it's not on your test. But you guys should read about it. It's cool. That less than 5% of elephants die from cancer versus up to 25% of humans. What does that mean to me? I think we should be studying elephants. Maybe we can mutate ourselves to have this zombie gene. Maybe we can stop getting so much cancer. Will you let us try that on you, Ben? Yeah, you give consent? Yes. Yes. Yes.
I remember that.
Everybody remembers that. It's wonderful. Epidemiology. Here's your definition. You're on the next page. Epidemiology, huge right now with our virus, COVID outbreak, and all the other outbreaks that have happened, pandemics. But this is the branch of medicine that deals with the incidence. We would say that cancer is also kind of a pandemic around the world. It is a big issue. Lots of people die from it. So that's why we're talking about epidemiology. So they deal with the incidence distribution, and possible control of diseases and other factors. So when COVID hit, all the epidemiologists are like, what is causing this? How is it spreading? How can we stop the spread? Let's make a vaccine. All of that was epidemiology. It's a lot of looking at data. And if I gave you guys time to look up like cancer data, there's a lot. So much, so many graphs that can be found and analyzed. How are we doing with COVID? Anybody know?
I think it's going down.
The cases are now,
There's-
they went down and then they came back. Now they're starting to go down again.
Some schools are mandating.
Yep. LA County, I think, is gonna do that.
Yeah.
And-
They already did. I think.
Really?
NSJC.
And
Yeah.
the,
Really? I know at this school, starting this week, teachers who are unvaccinated have to get tested every week. And if you choose not to get tested, you don't get to come to work. And guess what? You also don't get to get paid. So yeah, we're seeing these mandates. Yeah. Yep, because now we're approved, right? We're approved for 12 and up. Yep. And did you hear that the FDA has submitted for the approval of, I think 5 to 11?
Yeah.
So we're on track to get that age range.
I didn't feel a thing.
Oh, I got so sick on my second shot. It was not great.
Both shots, I didn't feel anything. So my arm being sore.
I think also just the combination of being pregnant and having the second shot really wiped me out. But okay. This is more just FYI info. Epidemiologists collect tons of data and statistically analyze to interpret patterns in health and the spread of disease. So you've probably heard of the CDC, right? They're the ones kind of controlling all of these vaccines and everything. Here's just a map, an example of some data we could see. Adult HIV prevalence, that's a disease we track. Where is it common? Okay, we can see that it's more common in some countries than others. So those are sometimes the things that epidemiologists will look like. If you like to look at numbers, this would be a great job for you, because you have the ability to really help the world a lot, have a great positive impact on the world, and you are just kind of like organizing these numbers and figuring out what's happening and where, so that doctors kind of know where to target and what to do. First used by a British physician named John Snow, not from Game of Thrones, this John Snow, who collected data in 1854 to find the source of a cholera epidemic in London. So basically people in London were dying of cholera. He found that it was all coming from one spot, one contaminated water spout. And once they found the source of that, they like shut it down and people stopped getting sick. So it's a very simple start to epidemiology. Here's like a map, I think, of that area. So all they had to do was remove the handle and the cholera went away. And you can still see the pump today. The pump. Probably not, but water doesn't come out of it anymore. Let's watch this video.
Epidemiology,
Whoa.
the backbone of public health. Not the actual backbone, which is often done by dodgy chiropractors. So if you are studying epidemiology, maybe as part of an MPH program, and you're finding it more confusing than the latest season of Game of Thrones, I don't blame you. When I first started studying epidemiology, I actually thought that I'd walked into a
foreign language class. In fact, if you're not a little confused, then you're probably not paying attention. Epidemiology often seems like a complex conglomerate of seemingly unconnected ideas. Again, very similar to the latest season of Game of Thrones. Things like study design, confounding, risk, standardization, life expectancy, attack rates, latency period, telepathy. Okay, not telepathy, I was just trying to make sure that you're paying attention. What I'm going to do is I'm going to try and simplify epidemiology, boil it down to a one-sentence definition that's going to give you some context. It'll be like a canvas onto which you can hang these various ideas so that when you take a step back and look at the big picture, you know exactly how these things fit together. Welcome back to this Global Health YouTube channel. My name is Greg Martin. If this is your first time here, please consider subscribing. I'd love to have you as part of this community of like-minded people who want to make the world a better, safer, healthier place. Now let me start by saying this. If you're working or you want to work in public health, then you absolutely have to have at least a basic understanding of epidemiology. So epidemiology really revolves around trying to measure two things: distribution and causation. And we're going to take a closer look at each of these in just a moment. But first, a big thank you to the University of Maryland Graduate School for their support. The University of Maryland Graduate School offer a fantastic online global health certificate, which if you want to study further can be applied to an online master's degree in health sciences. So if you're wanting to study global health, but you can't take the time off work to attend a full-time course, then this is a really good option for you. Click on the link in the description below to find out more. Now, let's talk about epidemiology. We're going to start off by talking about this idea of distribution. We're interested in how various diseases or other states of health, we could be looking at a health improvement, for example, how these things are distributed in society. So if, for example, we're interested in the distribution of HIV, let's take a look at what that means. Well, we're interested in who has HIV, where physically they are, and how that might be changing over time. In other words, we're interested in the demographic, the geographic, and the temporal distribution of HIV in society. Demographic, so these people old people, young people, rich people, poor people, males, females, people who do and people who do not understand all the references I'm making to Game of Thrones. So we're really interested in this broader definition of social demography, any parameter that will help us understand the different sections of society. Geographic, well, that's pretty self-explanatory. It's where physically these diseases or various states of health might be. And temporal, and here we're interested in how the incidence and prevalence of a disease is changing over time. So firstly, we're interested in the distribution of diseases and other states of health, and we call these outcomes. But we're also interested in the distribution of exposures. And these are anything that may cause or prevent disease in the community. Now, exposures could be environmental hazards, things like severe weather events, meteorological events like an earthquake, or water and air pollution, or exposure to chemical, radiological, or infectious disease agents, or exposure to social determinants of health, things like conflict, gender inequity, and poverty. And exposures can be things like public health interventions like tobacco taxation, or the provision of medicines or vaccines to treat or prevent diseases. And of course, these kinds of exposures improve health. And again, in this group, we've got the social determinants of health, things like education, employment, the protection of human rights. All of these things translate into an improvement of health at an individual and population level. And this brings us very neatly to the second issue that occupies the minds of epidemiologists, and that is the issue of causation. And here we're thinking about the extent to which these exposures really do or do not genuinely translate into changes in outcomes or the health status of people and populations. So let's talk about causation for just a minute because it's really important. When we see a correlation between two things, as one thing goes up, another thing goes up as well, we often incorrectly make the assumption that there's a causative relationship between these two variables. Now that's really bad science, and believe me, this happens a lot. So, for example, does eating ice cream increase your chances of being attacked by a shark? Of course, there's a strong correlation between ice cream eating and shark attacks because, of course, both of these things happen to happen on hot days in summer. But eating ice cream, of course, doesn't cause shark attacks. There's a confounding variable, which is an alternative explanation associated with both the exposure and the outcome, and in this case, it's hot weather. Now, don't ask me about people who swim in the sea and eat ice cream at the same time. That's just showing off, and you're offering the shark both a meal and dessert at the same time. You're asking for trouble. And there's quite a few other things that you need to think about when you see a correlation between two variables before you make the assumption that there's a causative relationship. And these include things like confounding that we've just talked about, but also bias, error, chance, reverse causation, p-hacking, and fraud, amongst others. And you can take a look at the Bradford-Hill criteria, which incidentally, even according to Hill, should not be used as a checklist. But I'm not going to get into that in this video. I'm going to create other videos, and I have in fact created other videos that look at many of these things. Take a look at them if you're interested. But for now, what I want you to take away is a nice, neat definition of epidemiology. So epidemiology is the science that considers the demographic, the geographic, and the temporal distribution of exposures and outcomes and the causative relationship between them. My channel has got a playlist that deals just with epidemiology if you're interested, so check that out if you want to watch more. Thanks so much to all of those that support this channel at patreon.com. I really appreciate it. Couldn't do it without you. And of course, a big thank you to the...
We support you. Okay. All right, so I want you guys to take a moment and I'll ask for some volunteers. Other than COVID and cancer, What are some other epidemics and things? Oh, man, you guys already have ideas. Good.
Spanish flu.
Spanish flu. Yes. Good. Ebola. That was big when you guys were pretty young, right? But you remember it, Mark.
2009.
The Black Plague. Yes. Yeah. Chickenpox, which we've gotten rid of mostly because we have a vaccine for that now. Yay. Polio. Yes.
Isn't the flight test coming?
Polio is also almost eradicated. We're so close. We have a polio vaccine. It only exists in a few countries. Mostly we've eradicated it. Eradicated means it doesn't happen anymore. Yes. Which one? Marcella. Really? Oh. SARS? SARS-CoV-2? That is COVID, I think. But there's been other COVID viruses. Yeah. Measles, good. So you guys are all thinking of diseases. Most of these are viruses that you guys are talking about here. There's other ones, like for example, you guys have heard like the opiate crisis. That's a big thing. I remembered that when he was talking about like the mandates on medicines and stuff like that. Doctors are cutting back now on the opiates that they give people. They found out that doctors, some of them were getting paid to prescribe these opiates, which then it was killing people. So now we are stopping that. You guys might have heard fentanyl is a newer drug that's coming around and killing people because it's way stronger than heroin. My husband was telling me he was looking at a documentary where, so fentanyl is like white, right? A lot of times you buy heroin, it's like black. They're actually putting stuff in the fentanyl to make it look like heroin. And so people are taking it and it's killing them because it's too much. Yeah, and they're cutting, yeah. Right. So, I mean, obviously you guys know, don't do drugs, but fentanyl, there was a cop who like touched it and then he passed out and like they had to save his life. Scary things. So I think the war on drugs, that's kind of an epidemiology
What about
situation.
the one person that was putting cyanide in Tylenol bottles, like the 60s?
I did not hear about that. That sounds terrible.
Yeah, he'd go around the stores putting
Huh?
cyanide in Tylenol bottles. People would buy it, die.
Yeah, I think fentanyl is lab created. Heroin actually comes from like a plant. Fentanyl is made in a lab. And so people know how to make it. Just like meth, people know how to make meth. You buy chemicals from the store and you mix them together correctly. Try not to blow yourself up. And then you have meth. It's terrible. Yeah.
There's a few guys in Hammond that blew themselves up trying to make meth.
It's terrible. Yeah. I mean, if we haven't learned, you might blow yourself up. That means probably don't do it. Right? Okay. You still have some time. Good. Smoking correlates with cancer. You have a graph there, yes? All right, good. Notice the blue graph is cigarettes smoked and the black graph is lung cancer deaths. We already know don't smoke cigarettes, right? I feel like cigarettes are a lot less common now. Like, yeah. I remember when I was like your age, like driving around, almost everybody in a car had a cigarette. Like cigarettes were way more common. I don't see as many people smoking these days. Vaping is another issue, but that's really terrible for you too. Both of them are terrible. This vaping came out and everyone was like, oh, that's better than cigarettes. It's yeah, it's terrible. And also the vaping seems to be like easier. It doesn't smell as much. There's a lot of like perks to vaping that make it better than smoking. Huh? Hookah is also very bad. If you've seen the hookah, like the stuff you smoke, it's very sticky. It almost looks like jelly with like tobacco in it. Oh, it's terrible. Yeah, it's terrible. Hookah got real popular when I was like senior year. There was these hookah bars everywhere. Terrible. Okay. So we need to know, what is a correlation? How are correlations depicted on a graph? This is something you guys are going to need to know. We're not writing this down yet. I'm hoping that you guys let me know, is this something you've done in math yet? Correlation coefficient. Basically, it is something you can calculate. A calculator will tell you how much of a correlation there is. So looking at this graph, would you say there is a correlation between these two things? Okay. Causation, different, right? Like you said in the video, we can't assume there's causation here. We have to look further into it. We know that there is causation for this, but it's obviously a correlation, right? Okay, so we can find whether we have a negatively correlated or a positively correlated. So looking at these points here, if you're, yeah, so yes, this is familiar? Yeah. Okay, good. So you want to know positive is up to the right, negative down a slope, right? It's like you're walking up or skiing down a slope. No correlation is just scattered, right? What do we call this line? Very good. So the closer our x's are to our line, the more correlated we would say, right? If all of our x's are on the line, let's say it's 100% correlated. The further away our data points are, the less correlated. Okay, good. Let's see if we can figure out. What would you say about the correlation for this one? Indirect or negative? Good. This one? Direct. Positive. Good. Oh. This one's really interesting. Cancer rates plotted against fat in the diet. So we can see which countries have more fat intake in their diet. And if you think about like German food, French food, Irish food, very fatty, right? If you think about Japanese food, Thai food, much more healthy, right? And we're also seeing their death rate in terms of cancer. So Mexico?
Mexico's like a bottom.
Mexico's down here. Mexico's pretty good. I mean, I'm sure
Yeah,
if you're eating enchiladas every day, it's not as good. But there is a lot of very healthy Mexicans. Yeah, that too. Are we even? Oh yeah, we're up here. I'm surprised Italy is not further up. When I think of Italy, I think of like spaghetti. Yeah, but even Italian food has a lot of pretty healthy stuff in there. Okay. This one?
No correlation.
Yeah. This one's interesting because it's like it's positive then negative, right? Yeah, I know.
No correlation.
No correlation.
Direct.
Okay, look, women smoke less than men based on this graph.
There used to be cigarettes.
It might be because this is another terrible thing about smoking and drinking. It will give you wrinkles. Bad wrinkles when you get older. Like you could tell if you look at like my mom, she was very, her diet not as healthy, but in terms of drugs and alcohol, I've seen her drink like 3 times in my life. And that's like one cocktail. She has almost no wrinkles. She's 60 something. I've seen 60 something year old women who are super wrinkly. And it's very likely that it's because they drank a lot, smoked a lot. Their voice is all different. I don't know that that's true. I think also being out in the sun a lot. I have an aunt who was always out in the sun. Her chest is very wrinkly, her chest and her face. So sun, drugs, and alcohol will make you wrinkly. So if you care about what you look like when you're 60, that's another reason not to drink and smoke. This one? Like we would say positive trend, right? But is it very correlated? Not really. Yeah, we do have a line of best fit. We can definitely see a positive trend, but not very strongly correlated, right? Okay, so that's getting us to this. We can actually find a number. You can calculate a number that will tell you the strength of the relationship. So if we get a number that's 1, that's like 100% correlated. 0, super weak. So notice these. It's called the R value. So R value of -0.9, the top left, that's strong, right? Because they're all very close. They almost make a line all on their own, right? And it's -9.9 because it's a negative correlation. This one, all those stars exactly make a line. You can't get stronger than that, right? This one we would say is 0. It's like none. So you guys already know the closer the dots to the line, the stronger. We do have a way to calculate that number. Okay, so this is something that you will do in an upcoming lab, I think. And also you're going to want to be able to do this in your IA, which you're going to be doing year 2. This is going to be your homework today. It's not very long. Not very long. So you have the link here. What slide is this? This is slide 102. Wow. Okay. So slide 102 for homework. I would write that somewhere, put it in your alarm in your phone. I will try my best to remember to remind you tonight. I'm sorry I didn't do that last night. Also make sure if you get page 10 and 11 done. This is what you're writing down for homework. Homework. Page 10 and 11. And what page is this on? Page is it?
14, 15.
Page 15? 15 using slide 102. Okay. All right. We have to finish our notes tomorrow because your combined test is on Monday. Fix your 6A syllabus statements and start working on your 6B syllabus statements as well. Oh, you highlight. Turn on the light, guys. 9:29. All right, you can go. Bye. Oh, remember tomorrow's the last day. Yep, due date's next week. So are you ready? I feel ready. Yes, I do. Sure, I am a bit nervous, but my gut is telling me everything's gonna go just fine. Yes.